The Big Bang theory proposes that our universe arose 13.8 billion years ago, and that it all began with the Big Bang. The universe eventually began to expand. Galaxies formed, stars were born, and planets were formed. Life evolved in one of those galaxies, the Milky Way. This life has progressed to the point where it is interested in the origins of life and its place in the cosmos. What if everything we know about the universe is incorrect? What if the Big Bang was not the beginning of the universe? And what we see inside our cosmos is nothing more than the result of being inside a black hole that arose from some parent universe. According to this unconventional theory, if black holes that originate in our universe give birth to infant universes, our cosmos could be nothing more than the result of another black hole. But what is the reasoning behind this claim? And what does living within a black hole mean? Join us as we delve into the latest notion that the Big Bang theory may be incorrect and that we have been living inside a black hole all along. Before humanity existed, before Earth formed, before the sun ignited, before galaxies developed, and before light could ever shine, there was the Big Bang. This occurred 13.8 billion years ago. But what about before that? Many physicists say there is no before that time began ticking. They insist that the instant of the Big Bang and pondering anything earlier isn't in the realm of science. We'll never understand what pre-Big Bang reality was like, what it was made of, or why it exploded to create our universe. However, some unconventional scientists disagree. These physicists believe that just before the Big Bang, all of the nascent cosmos's matter and energy were compressed into an immensely dense, yet finite speck called the seed of a new cosmos. This seed is assumed to have been almost unimaginably small, potentially billions of times smaller than any particle humans have yet observed. Yet it is a particle capable of sparking the development of every other particle, not to mention each galaxy, solar system, planet, and individual. If you really want to label something the God particle, this seems like an excellent candidate. So how is such a seed created? One theory that has been floating around for a while, most notably by Nikodem Poplawski of the University of New Haven, is that the seed of our universe was formed in the ultimate kiln. Inside a black hole is most likely the most severe environment in all of nature. Before we go any further, it's worth noting that many theoretical physicists have come to believe that our universe isn't the only one. Instead, we may be a part of the multiverse, an enormous array of separate universes, each with its own shining orb in the true night sky, which led to another related idea made famous by Stephen Hawking, that every time we create a black hole in our universe, we may be creating a baby universe that is only accessible to an observer who crosses inside that black hole's event horizon. Could our universe have been born by a black hole created in some kind of grandmother universe? And with each new black hole, do we give birth to a new universe? But what is the logic underlying these theories? The existence of an event horizon, a boundary that tells a radically different tale for an object outside of it than one inside of it, is the defining property of a black hole. Outside of a black hole's event horizon, any object will feel its gravitational effects because space is curved by the black hole's presence, but it can still escape if it moves fast enough or accelerates quickly enough in the right direction. It will not necessarily fall into the black hole, but it may be able to break free of the black hole's gravitational influence. When an object passes the event horizon, it is quickly engulfed by the black hole's central singularity. Because the fabric of space-time is severely curved inside a black hole, an infalling object will reach the singularity within seconds of crossing the event horizon, increasing the black hole's mass in the process to someone outside the event horizon. What does this have to do with our universe, though? If you were to take all of the known measurable forms of matter and radiation in the observable universe, you'd have to add up all of the following. Normal matter, made from protons, neutrons, and electrons. Neutrinos, ghostly fundamental particles that rarely interact with normal matter. Dark matter, which dominates the universe's mass, but has so far eluded direct detection efforts. Photons, or particles of light, which carry energy from every electromagnetic event throughout cosmic history. And gravitational waves, which are created every time a mass moves and accelerates through the curved fabric of space-time. We can see up to 46 billion light-years out in all directions at the farthest boundaries of what our detectors can detect. Using Einstein's most famous relation, E=mc2, you can calculate the equivalent mass of the universe by adding up all of the energy from all of these forms throughout the whole observable cosmos. Then, if you'd like, you may pose a fairly serious question. What would happen if the entire universe were squeezed into a single point? The answer is the same as it would be if you compressed any large enough collection of mass or energy into a single point. If this collection of mass and/or energy isn't charged electrically and isn't rotating or spinning without angular momentum, the total amount of mass is the only factor that determines how large the black hole is. What astrophysicists call a Schwarzschild radius. The Schwarzschild radius of a black hole with the mass of all matter in the observable universe is almost exactly equal to the observable size of the visible universe, which seems like a remarkable coincidence, raising the question of whether our universe is actually the interior of a black hole. But that's only the beginning of the story. Things get much more fascinating when we go deeper. A discovery in the mid-1960s transformed our understanding of the universe. A uniform, omnidirectional bath of low-energy radiation appeared from all points in the sky. This radiation had the same temperature in all directions, which was later determined to be 2.725 K, just a few degrees above absolute zero. The radiation had a particularly perfect black body spectrum, as if it came from a hot thermal source, and appeared identical to within 1 part in 30,000 no matter where you looked in the sky. This radiation, first known as the primeval fireball and now known as the cosmic microwave background, provided crucial evidence that our universe is expanding and cooling since it used to be hotter and denser. Going all the way back, this picture of the hot Big Bang appears to approach a singularity, the same condition found at the central interiors of black holes, a location where densities, temperatures, and energies are so extreme that the laws of physics themselves break down. Big deal, right? No. It is a major concern because if you compare all the properties of space outside of a black hole's event horizon from R to infinity, to all the properties of space inside the black hole's event horizon from R to zero, they are identical at every single point. Simply replace the distance R with its reciprocal 1 R, and you'll see that the black hole's inner and outside are mathematically equal. It's almost like taking a perfectly reflective spherical ball and realizing that the totality of the world outside of that sphere is now encompassed, albeit distorted, in the mirror image reflected on the sphere's surface. As our understanding of the universe has improved and been refined over the last few decades, 2 new discoveries have rocked the foundations of cosmology. The first was cosmic inflation, which now appears that the universe was set up by a rapid, relentless state of constant exponential expansion that preceded the hot Big Bang rather than arising from a singularity. It's as if there was some kind of field that provided energy inherent in space itself, causing the universe to inflate and the hot Big Bang to begin only when inflation finished. The second was dark energy. As the universe expands and becomes less dense, distant galaxies begin to recede from us at an accelerating rate, and the universe behaves as if there is some sort of energy inherent in space itself, refusing to dilute even as the expansion of space continues. It's possible that the origin of our universe was linked to the formation of an incredibly huge black hole from a universe that existed before ours, and that every black hole that's formed in our universe has given rise to a new universe within it. Unfortunately, the critical step of a uniquely recognizable signature that may tell us whether or not this is the case is missing. That is one of the most challenging tasks for any theoretical physicist, to discern the mark of a new notion on our observable cosmos from our old prevalent ones. Until we successfully take that step, work on these theories will certainly continue, but they will remain speculative hypotheses. We don't know whether our universe was created by the creation of a black hole, but it's a tempting possibility that we would be foolish to rule out at this time.